Hello everyone, so today we will be doing class 8 physics and the topic is work and energy, and we'll continue with what we have finished last time. So we divided into 3 sections. First, in the first class we did only about work, the factors that work depends upon, the numericals based on work, and then next we did with energy, all the definitions of energy related to energy, different forms of energy, law of conservation of energy, and today we'll be discussing power. Okay, class 8, so we've divided the chapter into 3 sections. First work, second was energy, now we're doing power. Okay, so what is power? Now before we jump into the definition of power, let us discuss what power means. So to do work, as we discussed last time, to do any work you need energy, isn't it? Without energy you cannot do work, right? But now how do you do that work? Okay, how fast you can do a certain work in a certain time defines your power. Okay, defines the power of an object. For example, say there are two persons, A and B. Okay, and A does a certain work, the same amount of work in say 10 minutes, and B does the same amount of work in 15 minutes. So who does more work? I mean, who does faster? Okay, who works faster or who does that work in a shorter time? So it is A. So when A does, so what do we say? We say that A has more power. Okay, A has more power than B. Similarly, let me give you another example. There are two machines. Okay, machine, and you put, say there are two grinders of different company, and in one you use 100 grams of groundnut, in other also you use the same amount of groundnut and you grind it. Now one grinds, say A grinds faster and the other one grinds 1 second slower. Okay, which means we say A has more power than B. So what is power? Power is the rate of doing work. That means how fast you can do a work in a certain time is your power. Okay, so how do we define power in physics? Power is defined as the rate of doing work. Okay, rate of doing work. That means how quickly a work can be done in a certain time. That's why power depends upon two factors, work and time. How much work is done in a certain time. That's why the formula for power is work done divided by time taken. Okay, in short we write the symbol of power to be P, work done as capital W and time taken as T. Okay, and the SI units of power is watt. Okay, it is measured in watts. Named after the scientist James Prescott Watt, you know that. So the unit, the SI unit of power is watt. Okay, W-A-T-T-S, no, not W-H-A-T. So from here we can see work. How do we get that power watt? The unit of work done is joule. The unit of time is second. So joule per second. Joule divided by second is your watt. You can also write power as joule per second. That will also be correct. Okay, you can also write watt. So instead of writing J/S, you can just write down watt. Capital W. Symbol is capital W. Okay. So 1 watt is defined as 1 joule per second. That means 1 joule of work done in 1 second. So the other units of watt is, other units of power is kilowatt. That is more amount of work. When you do a lot of work, okay, so when you do a lot of work, that is measured in kilowatts. And 1 kilowatt is equals to 1000 watts. Okay, and megawatt even more bigger. So when you know megawatts, so when you do a lot of work, when a lot of energy is consumed, okay, a lot of energy has been consumed, so we measure it in megawatt. So watt is a smaller unit than kilowatt. Kilowatt is smaller than megawatt. So 1 megawatt is equal to 1 million watts. And you can imagine 1 megawatt means a lot of energy consumed, just not a little bit of energy, but a lot and lots of energy consumed. Okay. Now, there is another unit of power, and that is your horsepower. That means how much the amount of work done by a horse. Okay, that is taken as 1 horsepower, and then 1 horsepower is equal to 746 watts. Okay, generally what horsepowers and hours are used written in English. So you can see over here the SI system and the English system is given over here, but that is not there in the book. For you, just remember 1 horsepower is equal to 476 watt. So these are the relation when the power is given in horsepower, you can convert it into watts. Okay, or if it's given in watt, then you can convert it into horsepower. So these are only the relations. Okay, and these are units only: horsepower, watt, kilowatt, megawatt. All these are units only, depending upon the amount of energy consumed, and also depending upon the places. Okay. So we'll be discussing about difference between work and power. So what is work? It is there in the book itself. I got it from the book, so you can refer to your book. If it's not clear here, it's quite dark, so if it's not clear, you can refer to the book. Okay. So difference between work and power. What is work? Work is done when a force applied on a body displaces the object. And what is power? Power is the rate of doing work. Okay. A work done, and the work done does not depend upon time. So if you just have to do any work, it does not depend upon any time, isn't it? You just do that work. And power is related to time. That means if you do a work in a certain time, if you do certain work in less time, you have more power. If you do the same amount of work in more time, you say you have less power. Okay, when you do more work in less time, more power. If you do more work in more time, then you see it to be power is less. The SI unit of work is joule and the SI unit of power is watt. So you have 3 differences. One, the definition of work and power. The second is work depends upon time. Work does not depend upon time, and power depends upon time. And the third one is the units. The unit of work is joule and the unit of power is watt. Next, we have the difference between energy and power. So, as I told you in the beginning only, that we have divided this chapter into 3 sections. First was work, second one was energy, and this is today we did power, isn't it? So, now first one we did the difference between work and power. Now the difference between energy and power. Again, this one has been taken from your book as well. So what is energy? Energy is the capacity to do work, or the ability to do work. Whereas power is the rate of doing work. Okay. Same way, energy also does not depend upon time. Okay, the energy that you spend, or the energy which is transformed from one form to another, they do not depend upon time. Power depends upon time. And the SI unit of energy is joule and the SI unit of power is watt. Okay, so it's almost the same as that of work. Okay, the difference is the definition only. Now we have some numericals related to power, and with this we complete the chapter. There aren't much about the power, which as per power you'll be doing more in your higher classes. So whatever we have in the book, this is all we have. Now we have numericals based on power using the relation P equals to W by T. Again, these numericals are chosen from the book itself. It's question number 12. Question says an electric heater of power 3 kilowatt is used for 1 minute. Find the energy supplied by the heater. Now, how much power has been consumed by the electric heater? 3 kilowatts. Okay, 3 kilowatts of power has been consumed. 3 kilowatt power has been consumed for 1 minute. Okay, that means the electric heater can have the capacity of doing 3 kilowatt work for 1 minute. So we have to calculate the work done. So P is 3 kilowatt. You convert this kilowatt into watt. So when you convert kilowatt into watt, what do you have to do? You have to multiply it with 1000. So 3 into 1000, you get 3000 watt. Okay, time is given in minutes. You convert the time in second. So 1 minute means 60 seconds. So we have done the conversion. We converted kilowatt into watt. We converted minutes into second. So you know the relation P equals to W by T. Just put the values. Work done. Okay. So from your work done, we have to calculate the energy consumed. Energy consumed means how much work has been done. So work is equals to, from this relation we get work equals to P into T. T goes this side, so P into T. What is the value of P? 3000 watt. What is time? 60 seconds. And when you multiply 3 into 6, you get 80 followed by 4 zeros. So it is 1,80,000 joules. Okay, so this is how we calculate the power or work done or time using this relation P equals to W by T. I have got another numerical. This is from page the same chapter and from the textbook. This is question number 13. Question says a pump is used to lift 100 kg of water from a well 60 meter deep in 20 seconds. If force of gravity on 1 kg is 10 Newton, find work done by the pump. Now see, the question looks very lengthy here, okay, but they have divided it into 4 sub questions. Okay, you have to find 4 different things here. It looks lengthy, but it is not actually. It's just that there is one question and they have asked you to find 4 different things. In the first one, they have asked you to find work done. So what is the formula for work done? Force into distance. How much is your force given? See, mass is given as 100 kg, acceleration due to gravity is 10 Newton, force is equals to m into g. You know that relation, isn't it? This force is equals to m into g. M stands for mass, g stands for acceleration due to gravity. So what is your m? M is your 100 kg. What is your g? 10. Okay, your g is 10. And how much is the distance moved? That means how much deeper is that well? How much do you have to lift that water up? 60 meter. So when you multiply them, you get it as 60,000 joules. So this is the amount of work done. Okay. How much is the potential energy stored in the water? The second part of the question asks you to find the potential energy. What's the formula for potential energy? mgh. So what is your m? M is your mass, 100 kg. What is your g? 10 Newton. And what is your h? Again 60. So you get the same value, 60,000 joule. Okay. The third question, power spent by the pump. How much power has been spent by the pump? Now you know the formula, P is equals to W by T. So P is equals to W by T. Okay. How much is your W? 60,000. We calculated it already. We have calculated the work done, which is 60,000 divided by time. How much is your time given? 20 seconds. Okay. So you just do the cancellation and you get it as 3000 watts, which can also be written in kilowatt, that is 3 kilowatts. Now the third part is power rating of the pump. Now, the same one, how much power does the pump spend, how much power does the pump have will be the same, that is your 3 kilowatt. You can omit this D also. So I've just taken this question so that because there are 3 different questions related to it, so that you can do similar sums. Okay, so here you know how to calculate work, here you know how to calculate energy, and you also know how to calculate the power. That's why I've chosen this question. Okay, so if it's not clear over here in this video, you can refer to the book. That this question is there in the book in the last page, that is That's question number 13. Okay. Now these are your homework. Numerators from your exercise. Question number 11 and question number 12. Okay, in the first question you have to find the power. And what's the formula for power? P equals to W by T. Your work done is given. How much is your work done? 4 into 10 to the power 5 joule. How much is your energy? How much is your time given? 10 seconds. So you just have to divide 4 into 10 to the power 5 divided by 10. Okay. And here it takes 20 seconds for girl A to climb up the stairs while girl B takes 15 seconds for the same job. How much work, compare the work done. So work done will remain the same because work, it says for the same job. Same job means for doing the same work. Okay. So when the work is same here, that's why the ratio of the work done will be 1:1. And the power spent by them, so what do you have to do? You have to calculate the power, power of girl A and the power of girl B by using the formula P equals to W by T. Okay, only your T will be different. P and W will remain the same. You simply have to compare, and if you have doubt, maybe in the next class on the board I'll do it for you. Okay, so till then, thank you.